We are here for a talk on power to the people who teach the people to code. Surprise everyone, you are now at a union rally. Marlon. Not quite, thank you.
Little bit.
A little bit, says Sheena, okay. Almost. Sheena O'Connell will be giving us this one. She has been programming since her early teens, so presumably 5 or so years ago. Sheena?
Lol.
She has worked on a wide array of projects and products, from embedded code and driver development for custom hardware to microservice architecture, data pipelining, and web development. She has taken active part in all phases of software development. But the far more important thing to us for this talk is that Sheena is also an incredibly passionate educator. She has given hundreds of people a start in coding and tech through her non-profit work, with either through direct guidance or through training trainers in education system design. She is passionate about codifying good teaching and learning practices in order to better support the world's tech educators. That's the part Sheena wrote. The part I will add is that Sheena is an excellent speaker, and this should be fantastic. So, Sheena?
Thanks. Hi, everybody. So, thank you. I'm Sheena. So these are my emojis. This is basically who I am in a nutshell. I've been coding for a long time, as Kim mentioned, and worked at a lot of different startups. So I enjoy working at places where there are a lot of different weird problems to solve and different hats to wear. I spent the last 5 years working in tech education. So I was working for a non-profit and built up a kind of a code school from scratch that takes noobs and turns them into professionals very, very reliably. And I learned a lot along the way that I want to share with all of you. So my education work started off with me teaching and training individual learners in different kinds of skills. Then I ended up teaching and mentoring the teachers, and I built up from there. So I did a lot to understand how brains work, how education should really work, how learning works. And I took that science of learning and I turned it into the engineering of learning as best I could. So that implied building some stuff, writing some code. We built like a learner management system and all sorts of cool automations and things. But that's fairly useless unless your human processes are also working pretty well, so the people and the tools need to mesh nicely. So my primary passion is around empowering people who empower others. So as an educator, I've seen some incredibly impactful things happen. You can change a person's life with some conversations. It's ridiculous. And I want to get other people to do that kind of thing. So I want to start off by talking about a perfectly normal classroom situation. It's something that many of us are familiar with, except if there are some homeschoolers, maybe things are a little different. But picture it in your head. You've seen this on TV at the very least. And there are a bunch of learners sitting in a class. There's a very steep teacher-to-learner ratio, so this resembles a classroom in a lot of different ways. There's a sage on the stage. The knowledge transfer is in one direction. There are projects and tests at certain times, and maybe there'll be a quarterly exam, maybe there'll be a big exam at the end of the year. It's kind of a slow feedback mechanism. Everybody moves at the same pace. So that sounds familiar to all of you? All right, so a picture's worth 1,000 words, so I'm going to draw one. So this is a picture of a perfectly normal classroom situation. All right, so we have a lot of people. We have some people that perform super well, strong. We have some people that are struggling. I'm not going to say weak, just it's hard here. And we have a whole lot of people in the middle. And the people over here are over here because maybe they work extra hard and they're conscientious. Maybe it's because they have high aptitude, they're really clever. Maybe they have extra support. And the people are over here because maybe they were sick and they couldn't catch up. Maybe they're there because they missed a few lessons, or they've got some problems at home, or they're struggling in some way. And then you have a whole lot of people in the middle. So this is the number of people. And this is the kind of ability to move fast through the course. So we got this normal distribution. And in a normal classroom situation, you'll have some people that pass and some people that fail. So I'm going to draw a line. Whoa. Everybody on the right of this line passes. Everybody on the left fails, right? And this is not realistic, right? Think back to your own schooling careers. The line was over here. It was somewhere to the left. It wasn't like half the people passed and half the people failed. It was over there. So how do you take that line and move it around? How do you take it, instead of tuning a course for the perfectly average student, how do you tune it so that most people pass? Because it is a tunable thing. There are a couple of different ways to do that. So the one way to do that is by lowering your standards. You can say, okay, we're just not going to cover as much ground. We're going to be more lenient on our tests and our exams. We're going to just slow down. We're going to lower our standards. So one way to move that from there to there is to be worse. Another way to move that from there to there is to notice the students who are struggling and help them out, or inspire the students, make them curious so that they're more willing to work on their own. So there's all sorts of different ways to move that line around, and those ways can be summarized as either you can either improve the quality of your education to move that line in a good direction, or you could decrease the quality of your education to move that line around. And yeah, think back at your own schooling careers, and I'm sure there are a lot of people in this room who are very bored. So there's this other guy named Bloom who did a lot of thinking about this distribution and how it works. He did a bunch of studies ages and ages ago, and he came up with this thing called the Bloom's 2 sigma problem. And it states that the average student tutored one-to-one using mastery-based learning techniques performed 2 standard deviations better than students educated in a classroom environment. That is a mouthful, and well, I'm going to go back to this picture to explain what that means. So the idea there is that if you take a perfectly normal classroom situation and you tune your curriculum and your delivery mechanisms so that exactly half the people pass and half the people fail, and then you change your delivery mechanisms, so same people, same output standards, same content, you just change how you deliver it so that you got one-to-one tutoring and mastery-based learning techniques, then this line will move across by 2 standard deviations. And so instead of it being a 50% failure rate, it's more like a 2.2% failure rate, just by changing the delivery mechanisms. So that's pretty cool. Why don't we just do that always? Why is this a problem? Why do you call it the 2 sigma problem? So the problem is that it's really, really hard to pull off. It's very, very operationally challenging. So this is mastery-based learning techniques, and this is how they work. So the basic idea is that you have a learning task, and you give a learner the thing to learn, and then you check if they learned the thing, and then if they learned the thing, you get them to move on to the next thing. And if they didn't learn the thing, you give them extra support until they've learned the thing. So you do one thing until they're done, and then you do the next thing. And this is tricky operationally, because then it means that people are moving at at different paces, their own paces, and that's that's just a challenge to pull off. But it makes a lot of sense because skills stack on top of other skills. So imagine if you were sitting in a classroom learning about recursion, but you hadn't quite mastered functions yet. That wouldn't work. It's a waste of time. It's a waste of the teacher's time. It's a waste of the student's time. But this is the thing that happens. Imagine trying to teach people about multi-dimensional data structures. If they didn't know the basics of data structures and basically how to deal with data structures, then the multi-dimensional stuff won't make a lot of sense. So skills stack on top of skills in ways that are pretty complicated and not all that obvious a lot of the time. And so it becomes quite important to think about how these things are related. And if a person gets left behind early, sometimes they get left behind completely. The next part of this equation was the one-to-one tutoring. So this is also something, if you just think about it for yourself, what's different between sitting in a classroom versus having a one-on-one conversation with somebody who wants to set you up for success? It's a very different situation. It's more engaging for the learners. They're not gazing out the window. There's more of a social contract. You're not hiding in the back of the class. You're not being distracted by your friends. And then the teacher can also focus on one learner and what they need. So for me to figure out how every single brain in this room is thinking right now and keep everybody engaged in the same way and say oh, you're missing this piece of information and you're missing that one, it's very hard for me. But if I'm having a conversation with one person, I can try to understand that one person. So So that's fantastic, but it's hard to pull off. And lectures in classrooms, I mean, it's not like they're pointless. It's not like they don't do any good. I mean, this is very much like a lecture. I hope it does some good. But it's hard to get right. And it's hard to know if you're even doing a good job, because in a normal situation, you get feedback very, very slowly, like at the end of the quarter, after the project. They're still useful. They still have a point. I don't think we can get away with just not dealing with people in groups sometimes, but they're very hard to get right. And it's useful to think, it's useful to not treat them as the default. So the other really, really cool thing about mastery-based learning is that it gives you mastery of teaching. I think this is super, super powerful. So to get good at a skill, feedback is very helpful. And if I'm teaching a person and I'm like, I explained something to them and I think I did a great job, and then I check and they don't understand it, then I didn't do a great job, and I get to know about that, and then I get to adapt my approach. And I can iterate on that. So the kind of stuff that I've been doing for the last 5 years is all based on mastery-based learning. So if we set up a system where everybody's self-paced and moving through content, and then a bunch of people get stuck on a certain thing, I would feel the pain of this. Be like, oh, you get stuck in this specific way. How can we unstuck you? Let's try a few different things. Okay, this works. And so it's very, very powerful for just like honing your own craft as a teacher. There's a science to this stuff. There's also an art. So through this work, like, I've learned a bunch of stuff, and this talk that I'm giving you right now is short. Like, how can I teach a room full of people how to like teach well in such a short period of time? It's very, very hard. But what I can do is I can plant a few seeds, and I can give you a couple of the biggest, most impactful lessons that I've come across that I try to get other people to follow. So this is the first one I want to cover. This quote: "Education is not the filling of a pail, but the lighting of a fire." We've all heard that before, right? It's poetic and pretty, and it's very meaningful. But practically speaking, what does it mean? So the way I think about it is this: we've got a bunch of time with a learner. I say learner, I mean student, whatever word you want to use. We've got a bunch of time, and we only really teach them for a small amount of that time. So in the situation that I was in, we had a bunch of learners that we effectively hired. Their job was to learn. So they had a 40-hour work week in which they were learning. And then if they got stuck on a thing, then we'd be like, okay, cool, tutoring sessions, sort that out. And so this is like 40 hours, and then we'd be talking to them for like maybe 1 or 2. And the goal of that conversation, or those conversations, was not so those conversations go really well. It's about the rest of this time. So you don't just want to like put some knowledge in a person's head and be like, cool, see you next time, I'll put some more knowledge in your head. You want to set them up so that they can seek out knowledge on their own. Same thing with different kinds of workshops. There's a lot of like volunteer-run education events in the Python community. There's Django Girls, there's Humble Data, there's probably a bunch that I don't know about. And these things are freaking beautiful, and it's like a day or 2 days, and then like hopefully a career. So it's about planting seeds. So it's not simply about knowledge transfer, although that does happen. Like sometimes the person just doesn't know a thing, and it's like, okay, cool, here's the thing that you need to know. Sometimes it's about answering questions. That's very helpful. I mean, if a learner is like, I'm stuck on this, and that's good information for you to use as a teacher, that is raw material. Questions are great. Is it about solving their problems for them? Not so much. So this is one of the biggest anti-patterns I see in teaching, especially in teaching code. If somebody is struggling, and then the teacher or a coach is like, let me help you with that. You can't teach a person to ride a bicycle by riding their bicycle for them. But somehow this happens a lot in coding, so it's this is just worth highlighting. Teaching is about planting seeds. When you plant a seed, you don't really know how it's going to grow. You can try to get the soil good. You can try to water it in the right way, but it's not like carpentry where you can be like very, very precise about things. It is a nurturing act. So if your goal is to set a learner up so they can continue to learn and grow on their own, then you want to set them up with certain mindsets and next steps. So if you have a class or a session or whatever you want to call it with a learner, by the end, they should have some enthusiasm and curiosity. They should feel like this is something that's worth getting good at. This is something that I would like to pursue. They should also feel like this is not this is something that they can do. They shouldn't say like, this is great, not a chance. There should be that confidence. And that confidence should be applied in a forward direction. They should have some next steps to pursue. And they should be able to take those steps. So the steps need to make sense for them. If you're like, okay, cool, we've done Hello World, Kubernetes. No, that wouldn't make sense. So well chosen next steps, and that's partially the job of the teacher is to help craft that journey, guide that journey. Tech is vast and huge, and so you don't want to guide it too much. You want to allow curiosity to lead people in different directions. So there's a bit of a balance there, but a lot of people do try to run before they can crawl. So it's useful to have somebody who can act as a guide. The next thing worth talking about is a growth mindset versus a fixed mindset. So this one's a tricky one actually, because there is a replication bias crisis currently in social sciences, and so growth mindset is something that's been being looked at right now. So it's a tricky one, but I'm going to go through it and tell you about some of how I see this stuff. So yeah, so I'm sure most people in this room have heard about growth mindset. Yeah, it's part of the pop psychology discussion at the moment. It's very it's very normal to hear about it. So I'm just going to define some things very quickly. The fixed mindset is the belief that you either have it or you don't. Somebody with a fixed mindset, if they fail the test and they're like, I'm just bad at that, I'm not going to try anymore, I'm going to do something else, I'm going to give up. Whereas a person with a growth mindset can take failure as information. So I failed the test, maybe I didn't study hard enough, maybe I can go get some help. The fixed mindset has shame associated with failure. It's like identity associated with failure, whereas a growth mindset, the identity is more around like I can change my abilities in this way. And I love Huberman Nab, it's so good. So he's got a really cool podcast episode about it, which I highly recommend. So check that out. So I'll share a link to these slides later on, and you can access the links. So growth mindset is cool. If you don't take failure personally, then you're more willing to fail. It's a lesson. If you're struggling, then it's like, oh, I'm learning. I'm moving forward. A person who doesn't have shame around failure is more willing to expose themselves and say like, hey, I need help. And it's also about being less judgmental when other people struggle, because if you see struggle and you're like, oh, you're just hopeless, then you're not a helpful person. So it's pretty powerful in a lot of different ways. It's also a spectrum. So it's actually a lot of spectrums. So I might have a growth mindset when it comes to coding. I might be like, oh, I can learn new tools because I've done it so many times. I've learned that, I solved that problem, it was hard, that was hard, I made it. But maybe when it comes to my ability to sing, I'm like, nah. Or my ability to play a musical instrument, or my abilities in other things, I might have more of a fixed mindset about that. So that's worth knowing about. The other thing that's quite cool is that yes, it is in itself something that can be grown and worked on. So a lot of people, when they grew up, they built an identity about being right about things a lot, and then when they hit an actual challenge, and they're like, whoa, then it starts to become a problem. But if you're aware of the problem, you can start building up your capability to accept struggle as a good thing. So it's worth fostering. It's worth fostering a growth mindset in the people that you teach, obviously. If you say, oh, you're struggling, fantastic, that means you're growing, then that's very different from saying, oh, you're struggling, maybe you should do something else. And it's also important to foster a growth mindset around yourself as an educator, because, again, this is, there is a science to education. The stuff is under constant study right now, how brains work, how minds work, how memory works, how understanding works. It's something that it's being actively researched, and it's worth knowing about that stuff, but it's also worth honing and practicing the art and getting feedback so you can get better as a teacher. I have the one time I met a teacher who was like, teaching, you either have it or you don't, and that's not right. So yeah, so another really, really cool thing about mastery-based learning is that it does encourage this kind of growth mindset. It does encourage confidence. So with mastery-based learning, a learner will stick on a thing until they're ready to move forward. And so if you move forward when they're not ready and that keeps happening, then they're just like, oh, I'm useless at this. But if you get a person to work at a thing until they've got it, and then they struggle with the next thing, and then they get it, and then they struggle with the next thing, and then they get it, maybe they won't get the whole course. Like maybe they won't get through all of the content, but even if they get through like the first half, it's like they got something from this. So it's very powerful. Like to show a person repeatedly that if they push, they'll get through a thing. That's super cool. So let's zoom in a little bit. So let's say I'm having a lesson with a learner. I notice that they're struggling with a thing. How am I going to deal with that? I need to be prepared. I need to understand the thing myself. That's very, very important. And then I enter the lesson with this person. And the way I think about it is as a little loop. I spend some time understanding the brain of the learner, and then I'm like, there's the gap in your understanding, and then I illuminate. So assess, make sense of them, and then help them make sense of the topic, and keep looping over that until eventually you run out of time, or you've gotten through the content. At the end, you want to catalyze further growth. And all of this is underpinned by a growth mindset and metacognition. So metacognition is kind of a new word in this presentation. It's just about building awareness and understanding about how a person's thought processes work. It's thinking about thinking. So a way that I think about teaching code is I actually teach people code in order to teach them to think and teach them to learn things on their own, teach them the value of self-assessment, that kind of thing. So if you are able to get the learners to look at their own thought processes critically, then that's gold. So practically speaking, what does that mean? So teach them how to learn. There are some techniques that are more powerful than others, and we see like people do all sorts of silly things when trying to learn a new skill all the time. Like in code, you'll get people who just like watch videos and build up this feeling of familiarity and excitement. They remember the emotional reaction they had to watching the video, but not necessarily the content itself, not necessarily the skills. Or you'll get people who watch or like read a thing and then read it again and then read it again. That's not even a good way to memorize things, let alone understand them. So there are a lot of like bad practices that people fall to naturally because they are like often leaning towards things that feel easy and feel familiar rather than the things that feel hard. So yeah, practically speaking, you should be a guide about that stuff. So zooming in on this little loop of like assessing a person and then filling in the gaps. Why do you think I put a test tube over there? So you got to be a little think like a scientist when you're talking to somebody, when you're talking to a student. If they're confused, don't be like, oh, why aren't you getting it? Like, you want to be curious about why they're not getting it. Like, try to be like, oh, you're not getting it. Do you think this? Do you think that? And come up with little theories about which pennies did not drop, and come up with ways to test if those pennies dropped or not. So a really good way to do that is just to like write a little piece of, well, with the foundations anyway. A good way to test a person's understanding of different things is to write little blocks of code with some print statements in it and say like, what does this code do? And if like you can get quite a lot of information about people's understanding or misunderstanding from doing that. The next thing you want to do is maintain a very good signal-to-noise ratio. So you want to get as much signal as possible about how the person's brain is configured at this point. And so if you ask them a trick question, and they get it wrong, it might be because you tricked them, or it might be because they didn't understand. If the person is anxious and you ask them a question, they got it wrong, it might be because they were anxious or because they didn't understand. So you always want to try and reduce those variables so that you can actually get the person's brain. So it's important to think about just keeping them calm. Like, teachers should always play good cop. We're training coders, not parrots. Yeah, so this is something I say to trainers a lot. So often what'll happen, especially with new coders, where they're still in that phase of like memorizing things and not necessarily understanding how the code works. You could ask a learner like, what does the return statement do? And they can give you a perfect, beautiful textbook definition that they read about on the internet. And I've seen a lot of teachers be like, okay, cool, you understand it, let's move on. If you're trying to assess a person's understanding of code, the best way to do that is with code. So always like, no, just don't trust words as much as like, what does the code do, or can you write the code? I mentioned this a little bit earlier. It's useful to come up with examples of code where there's print statements or something like that in there, so you can see very, very explicitly like what the code does when it runs. So you can say to the learner, what will this do? Like, what will it print? Tell me exactly. And they can come up with a theory, and then you can be like, let's test if this is correct or not, and you can run it, and they can see. It's a lot more powerful often than saying, please explain this code to me, because you might fall into that parrot trap a little bit, and they might just be bad at explaining stuff. That's another problem. The next thing is about illumination. You want to line up some pennies and watch them drop. So in general, you want to be a guide more than a lecturer. You want to say, look over there, instead of like, here is the information. Sometimes people are missing information and you need to just tell them. But a lot of the time you can lead with different kinds of questions. Like on print statements, again, you can say, cool, you said it would print this, this, and this. Which print statement printed this? How many times did it run? Those kinds of questions are pretty powerful. You get a lot of aha moments just from that. It's also useful to have a couple of tools in your back pocket. So the more you teach people and the more you like really focus on plugging gaps in their understanding, the more you know where those gaps are likely to be. So that's the one part. And the better you are at plugging those specific gaps. So for example, like I've taught a lot of people very foundational stuff. And in Python, when people learn Python for the first time, a lot of people get confused about return statements versus prints. Like they think it's the same because of REPLs. And JavaScript is also a problem around that. So like I know about that problem, so I can go and sniff it out and be like, do you have this problem? And if they do have that problem, then I can explain why this is a thing that comes up and be like, oh, don't worry, lots of people get confused about this. This is why people get confused about this. And like, here is how it actually works. So it's useful to build up a little, like a toolbox or a library in your mind around these different things. The next one is trust no one. And I mean that with love. So a lot of the time, if you explain a thing to a person, you're like, do you understand? They say yes. Don't believe them. Like sometimes they're right. Sometimes they're nervous. Sometimes they're trying to impress you. They don't want to look dumb. So it's good to be like, oh, cool, yes, fantastic. Let's just check. The next thing that we spoke about is catalyzing further growth. So retrieval practice is powerful. Like if you want a person to remember some stuff, to really remember some stuff, then retrieval practice is golden. But again, you don't want to encourage memorization over understanding because it's a danger here. So you don't want to say like, just memorize this stuff. You can say rather, we just had a session where we covered X, Y, and Z. Go have a cup of tea, walk around the block, whatever you do to clear your head, and see how much you remember after that. And then tomorrow, see how much you remember. And remember how I was assessing your understanding. See if you can push your understanding further by assessing yourself. See if you can use these techniques on yourself. Remind them that learning is hard. That when they're struggling, that's a good thing. And that it's really worth leaning into. Make them understand that having the opportunity to be wrong is a good thing. So self-assessment is scary sometimes because you need to set yourself up with situations where you could answer questions wrong and you can fail and it doesn't always feel good. But to reframe that as an opportunity is very, very helpful. So what I used to do at my old job was we would record all of our teaching sessions, like all of them, and then we'd pick some at random so that we could review each other and coach each other on how to teach well. And one of my favorite things that I saw was one of my guys he somehow got the learners to break out into like wild giggles every time they got a question wrong, and it was just like it was just like such a healthy, positive interaction. They're like, "Oh, lol, we're so silly. Okay, cool. Let's figure this out together." It's like if you can make that into something that's actually fun, then that's great. Psychological safety is critical. If people feel dumb, if you get people to feel dumb when they get things wrong, then that's terrible. And it's also really important to celebrate small wins, especially if there was a struggle in that session. So if you're working with somebody and they're like just not getting it, and they haven't been getting it, and you battle through this thing, and then they get it a little bit. Like if you notice a level up, like flag it and be like, "Hey, you just leveled up. Earlier on, you were struggling with this, and now you're getting all the answers right." People don't necessarily notice that in themselves. They are plugged into their emotional feeling of like what's going on. They'll be like, "Oh, I'm struggling, I'm struggling, I'm struggling." They won't necessarily see the wins, but you do, and encourage them to do it themselves. The next thing worth mentioning just briefly is the protege effect. So something that's like for me, for this to go well, for this session now that I'm having with you to go well, like I'm hoping to plant some seeds. One of the seeds is like, I want people to be excited about education because it is something that's a craft that you can get better at, and it is something that changes lives. It's also something that's really good for your own skill set. So this is something that's really well studied, the protege effect. I'm sure many of you have heard that a great way to learn is by teaching, and it really, really is. Like it's not a nice thing that we say to each other so that there are more teachers. It's quite legit. So just in preparing to teach a person a thing, you benefit quite a lot because you'll think about the content from a different direction. So like it's very, very powerful. Even if you're just pretending that you're going to prepare to teach somebody, you have a duck that you're going to explain things to. It's helpful. Then the actual act of teaching a person a thing and coming up with theories about how their brain works, it's retrieval practice, but it's even more than that. It helps you build mental frameworks about how things work. The learners who you're teaching are going to ask you questions, and that helps again with retrieval, and that helps again with framework building. And some of those questions are going to be like really left field and weird, and you're going to be like, I didn't think of that. And that's very, very useful. So that's all great. I actually took out a slide from here, and I shouldn't have taken it out. There's this woman named Dawn Wages. Has anybody here heard of Dawn Wages? Okay, yeah, he's heard of Dawn Wages. So she is the president of the Python Software Foundation. And is it the Python Software Foundation? Yes, it is. No. Well, chair and president are, yeah, they're about the same, yeah. And she has purple hair and she's lovely. And she's a organizer of DjangoCon US. I met her through organizing DjangoCon Africa. And I was super impressed by this woman. She's quite hardcore. And yeah, so she got her start in Python programming through a Django Girls event. Like, she showed up to this event, she had like a little bit of CSS, she'd learned some SQL, she was like, I don't know if I really like this, and she went to this Django Girls event, and there's nothing magical about Django Girls. Like, it's got a lot of rough edges in different ways, as so many different things do. But the fact that she showed up, and somebody else showed up to coach her, like, that sparked something ridiculous. So Dawn Wages, like, she moved up the ranks in the Python community in a very, very big way. But beyond that, she helped set up like DjangoCon Africa, which changed lives. Like teaching sends shockwaves. It's freaking powerful. So yeah, many reasons to teach. So for that said, I'm going to shamelessly plug the Guild of Educators. So I made this thing recently because I've always wanted a guild, and cool. Yeah, so the idea with the Guild of Educators is first and foremost it's a community for people who are interested in tech education specifically, ideally around Python, but I am not closing doors to anything else. And I want to empower educators because education's cool and it's not treated like it's cool enough. So the empowerment comes around sharing skills. So like I've learned a bunch. I've learned a bunch like the freaking hard way over the last couple of years, and I want to help other people not fall into the pitfalls that I fell into. So I want to share skills, but I also want to hear about other people's stuff that they've gone through, because like I've been teaching in a specific context with specific resources, with specific tools, and it's different from a lot of what's out there. So sharing skills, sharing opportunities as well. So like if there is a Django Girls event and there's like a community of teachers, you can be like, hey, do you want to check that out? There are a lot of people who want to get into tech education and they don't know how. So I want to make ways to help those folks. The initial focus of this thing is going to be volunteer-run Python education events, just because that's the niche that I'm in, that's the community that I'm in. But again, it's about a focus. It's not about closing doors. I think it's a very good initial focus. And I'd like to invite you to join us if this is your jam. Like, I think community itself is very, very powerful. One thing that I've noticed a lot is that there are educators who become pretty jaded about education. Some of them leave and come back. Some of them leave and never come back. And it's a real problem because it's such a beautiful thing. And I think that by having a community of people who are able to support each other, give each other advice, be like, oh, I feel that too. Like sometimes that's very helpful. I've seen educators overstretch themselves, shoot themselves in the foot in different ways where they're just like, I poured so much of myself into this and then this happened. Having people who've been through it is very powerful. So yeah, if this is your thing, then this is a link that you can click on. And there's right now it's quite small. There's a little Discord server. We're going to start doing some online events soon. And I have high hopes for it. It's still small, but I'd like to invite all of the education nerds to come and join. You can support us in different ways as well. That's not happening. Yeah. Last but not least, I wouldn't be a good educator if I didn't give you some homework. So learn about learning. It's really, really cool. So if you scan this QR code, it'll take you to these slides. And the first two slides are a bunch of links. There are some books there. There are some courses there. There's also my stuff there. And go teach someone. Try it out. Yeah, that's it. Thank you.
I did tell you she was good.
Thanks.
Questions? Anyone got any questions? Many questions. We'll start. Yeah.
Wow. Thank you so much. What a lovely, lovely session. I think for me, yeah, I needed to be in this session. This is really talk right through to my heart. That's where my heart is in terms of like, especially developing teachers. That's what I do, and you really inspired me today to do more because teachers need us. I'm also a teacher, but I'm a teacher in a different space. I'm not in a classroom. So yeah, I really enjoyed. I will definitely join you.
Thank you.
Okay, so this is on. So I'm running risk of completely dominating this entire discussion. We had a little bit of a meltdown earlier in the speakers' room just about the state of education. So if I had to pick one question, it would be around this idea of you can't estimate outcomes, you can estimate effort. Okay, so you can say, I'm going to put in this effort as a teacher or a mentor or whatever. I can't say what the outcomes will be.
Yeah.
But I can say that I'm going to show up for these sessions, I'm going to do this prep work, whatever. But the problem is the entire way the academic structure is structured is orthogonal to that.
Yeah.
It promises outcomes.
Yes.
And what I often
And on a
I'm saying
schedule.
this- and what I often see is it's a bit of a arms race in terms of language and so forth, where if you as an institution come out and you say, you know what, coding's really hard, it's probably going to be the hardest thing you ever try, and like you're going to suck for a very long time, and you might even not get it right. And this is what we can offer.
Yeah, then
You
they'll
know,
go somewhere
you're
else.
competing against someone who's saying like, become a full stack developer in 3 weeks,
Yeah.
learn these languages,
Yeah.
build the app of your dreams.
Yeah. It's so hard. Like, that is a big problem. That's
So,
one of the biggest problems.
I have no idea how to solve that.
Yeah.
Yeah, so I'm keen to hear your take on that.
So, yeah, this is a problem that I think about a lot, and it's something that I've hit up against as well in a very, like, I've dealt with people who've gone through those Sharky programs. So, I mean, picture in your mind a used car salesman, right? There are a lot of those in tech because software development training is opaque to the people who are buying it. Like, that's why they're buying it. And it's a huge industry. Like, across the world, it's like multi-billion-dollar industry. It's gigantic. It's like, it doesn't fit in my head how big this is. And so there are a lot of people who come to this game to make money. And like, so there was this one course for this one organization. They were charging upwards of $1,000 a week for a master all of this stuff in 12 weeks. And I dealt with some people who came out of that program and couldn't really understand how functions worked, and they passed, you know? And that's gross. So the arms race is real. I think that I'm not sure what the solution is. I think that part of it, I think that there's a big problem in the ecosystem. That's part of the problem. Another part of the problem is that you get code schools with, like, their hearts are in the right place. They're not there to rip people off. And they look at the industry as a whole and they're like, how do people do this? Oh, they do it like that. Because look at that wonderful marketing material. And then they imitate the sharks. And so I think that there's a lot to be said around like visibility of the problems and getting people to not just buy a course with big promises, but to look at the teaching approach, like get them to actually care about that, get people to understand like different approaches to education, like this whole mastery-based learning thing. It's so solid. So if I see like a code school that's advertising that, I'm like, I will pay more attention to you, because I know it works. Yeah, so there's that aspect. There's like, I think there's something around partnering with industry as well, finding organizations that hire software developers and saying like, how can we work together? Because if you have, if you're like plugging talent into some like a hardcore environment, then it's like, okay, this gives you some street cred. I think there's also something around educating the teachers themselves and saying like, all right, we know what's up, we have high standards, we believe in these people. So I don't think there's like one thing that'll solve it, but I think there's like a lot of different ways to just like nudge the ecosystem in the right direction. But it's freaking hard, and I yeah, we can just try.
Thanks.
Yeah.
We've got the time for one more, and David has his hand up. I just want to note, you can tell the academics in the room, of course, they use words like orthogonal.
Yes.
So briefly on that problem, at the end of the month, we'll be having a seminar with the IITPSA, the Institute of IT Professionals of South Africa, who've just come up with a certified coder, certified member of the IT professionals, and as DevDev, which is a working group with Coder Level Up and them, we're trying to figure out how to make that relevant for developers. So if you want to be part of that conversation, let's actually make that real, because the goal there is to say this education will get you there. My question is, in the mastery thing, you talked about keeping on splatting against the same problem again and again until you get through it. I'm wondering how you balance that with widening the walls to have options so that we don't have frustrations. Like, just pragmatically, how does that work out?
So there will be frustrations. And sometimes learning is not a linear thing, but I think it's about being aware of the non-linearities. And this is also something that we spoke about a little earlier. It's like, how do you get a person to understand something like loose coupling? Like, you don't just tell them about it and be like, okay, we're going to learn loose coupling until you get it right. Sometimes you have to give them some, like, you line up some pennies, and then you give them some foot guns so they can shoot themselves in the foot, and then you can say, like, oh, your foot, sorry, what happened? Then they're like, oh, I shouldn't have connected things like that, because when I changed that changed. So there is something around, like, setting up, I don't know, different adventures that need to happen over time. It's not something that's very pure. Or like, I don't think mastery-based learning can be applied in like a super pure way where you like just learn this one concept, then you learn the next concept. Things do get mixed up, and you do need to allow creativity as well, and exploration as well, and curiosity. So it's not pure, it is messy. Yeah.
Thanks, Sheena. And unfortunately, that is pretty much it, because it is now 1:45 and we have to set up for the next talk. But I would encourage you, please find Sheena after lunch. Or after lunch. At tea is the word I'm looking for.
Yes.
Sheena is around. She has one of those organizers badges on. You can see her. And Sheena, I know, will be welcome to questions all day.
Yeah, come and chat to me whenever.
Perfect. Thank you very much, Sheena. That was absolutely fantastic.